Okay, so now we're going to be playing with a compass here and a ring of NeoPixels. So this is GY-271, and this is just a ring of 16 NeoPixels. Okay, really straightforward. Uh, so we have LED count is 16, the pin's 11 for that, and we need to figure out how to get data out of this compass chip to put lights on the NeoPixels. So what we can do here, this is a GY-271. Chances are we need to actually find the chip. So I've already got it up here. The GY-271 uses a QMC 5883. So I'm going to copy this and then sketch, include library, manage libraries. It's going to take a while to load up, updating my list. There we go. And then paste that, and then wait a second. For some reason, you don't hit enter, you just hit wait. All right, so we got QMC 5883. I've already got it installed, but if you don't install that, cool. Okay, so let's go to File, Examples, and then way down here, not HMC 5883, right? Don't use that one by Adafruit. Let's go all the way down here. You can't quite see it in mine, but I'm going to go to QMC 5883 and go to XYZ because that's all I want. I just want the XYZ sketch. Okay. So 9600 is lame. Let's do 115200. Cool. That's gonna really help out if you're using ESP32s. Just set everything to 115200. Okay. And so looks like it's not gonna do much here. It's gonna open a serial, initialize the compass. Okay. Well, initialize the object called compass, which is made from the library for this. Okay. Create three integers: one x, one y, one z. Okay. Do a read, and then from the reading, we need to get X, get Y, and get Z, and then it's going to print them all out. Okay? So let's upload that. And then we're going to show some really fun math here through Arduino. We might have to do some visualizations for it. I'm not sure. We'll see. Okay, so we're uploading the sketch. I'm going to open up Serial Monitor now. Okay. And there we go. We've got some readings here. So X, Y. So if I were to turn this, there we go. Now we're getting all sorts of readings. Okay. And Z's not changing much, but maybe if we pulled it up like that. There we go. Now Z's upside down, it's pulling negative. As Z's right side up, it's positive. Right? So as we move this around, it changes all these readings, right? Cool. Okay. So we're going to do a lot of copying and pasting for our sketch here. Okay. So up here, see, so we included NeoPixels in here. And I'm going to include the compass library. Looks like there's a lot less to it. See, so I'm going to create an object called compass. There we go. Initialize the compass. Okay. And now we're going to take X, Y, and Z and do something with them. So I'm going to open up Serial Monitor again. Let's observe these pieces of data here. So Z is positive, looks like up to 1600 or so. 1700, 1800. Not quite sure. But if I turn it upside down, negative 1900, negative 22. Okay, turn it to the side. We have Y being negative and positive here. There we go. Y is now negative 21. So we've got quite a range on here. Okay. Let's see. How do I explain this? So there's a function called arctangent. Okay. Arctangent, and you get 2 points. So let's go to the Arduino website and see if it explains it well. So Arduino .cc. Okay, and we go to documentation, reference, and we go down to math. Here we go. Math, maybe not. Yeah, maybe it doesn't pop up here. Atan2 is one of my favorite commands, so I'm going to type in Atan2. And I guess I should type in Arduino. There we go. And it's part of the math editor, so it should have been on there. Maybe my eyes don't work so hot. Okay, yep. So it doesn't really talk about it much. Okay, so I'll explain how that works here. So with arctangent 2 points, which is what it stands for, right? So I'm going to do int x, int y, okay? And then float rads, okay? A radian. So if I were to take a circle and I were to take the diameter, or the radius of that circle, that length, I were to place it around the perimeter of the circle, that would be 1 radian, okay? So I'll do the math in a little bit here on how many radians are in, like, how many degrees a radian is, and then we'll do some conversions. But for now, we're just going to turn it into rads, okay? And it has a decimal. So all this stuff has decimals, so we need to use a float function, okay? So I can do, let's see, so I got to do a read first on the compass, right? So compass.read, and that's a function, so it still needs parentheses, semicolon. Okay, so we're going to read the compass, and we're going to do x equals, let's see, compass dot get x, okay? And then y is going to look very similar. It's just going to have some y's in it. There we go. Okay, so we got x and y here, right? Okay, so now we do, not float, we do rads for radians. Rads equals a tan 2 x comma y. Okay. And from here, let's see, we already have a serial.begin here. So we're going to do a serial.println. And we want to print out rads. And let's look up how to, well, we'll just leave it like that. I wanted to look up how many, like how to specify how many decimals. We'll just let it throw as many decimals as it wants out for now. Okay, and that semicolon, and then we'll do a delay of like 100. That way we don't overload. Well, we won't ever overload the serial monitor, but I hate that super fast stream. I'd rather just have it like slowly stream so I can read the previous and next one. Okay, we're gonna compile this. Oh, x equals cannot convert. Oh, whoops. That's a function. My bad. How embarrassing. Parentheses on all the functions. Okay, so we create the x, we create an integer called y, we created a variable with decimals for rads, and then we read the compass and check it out. Okay, let's open up the serial monitor here. Let's see, do I have it floating somewhere? Click that. Oh, there it is. Okay, I see. Okay, here we go. So now I've got it at an angle. I guess I should probably show you guys this. So here it is, right? Pretty flat. And now I've got it at an angle here, right? So it's negative 2.5. Like, it's pretty steady here, but I keep rotating it. And negative 3. Oh, watch this. So negative 2. So negative 3, negative 3.13, 3.12, 3.14. Oh, and it jumps over to 3.14. So keep that in mind here, okay? So now I'm taking it this way, turning it over, and it's going slowly down the other way, right? Incrementally, like nicely. But there is, so I'm holding this see, to the side here, somewhere around here, there it goes. It jumps from negative 3.14 to positive 3.14. Okay, keep that in mind. Okay, so that's what it's returning. So a value from negative 3.14 to a value of positive 3.14. Okay, so a value of uh, negative pi to a value of pi. Okay. Okay, now that we know that, let's turn it positive. Okay. So now let's say, let's see, serial print. Yeah, we'll keep that. Well, we'll do it before this. So we're going to say, let's see, rads plus equals pi. Is it capital Pi? Yeah, there it is. Plus equals pi. Okay. And let's see if we can keep it positive now. Going to upload it and check out the serial monitor. So right now we're getting negative and positives, right? Let's try to keep it all in the positive plane. All right. So there it is. Okay, so now we're going 6 point, what would that be? 6.28? Yeah, about 6.28 to 0. So as I'm slowly rotating this thing, I go from 6.28 to 0. So now I'm all in the positive realm. Okay, so we're getting closer to what we want. Okay, so now let's do a little math here. So there are 360 degrees in a circle, right? A full 360 degrees. What I'm going to do here is take 360 and divide it by, let's see, what are we getting here? It's 6.28, right? Yeah, it's about, yeah, 6.28. Okay. So 360 divided by 6.28 equals 57.325. I'll call it 57.325. Okay. So we need to make an int angle equals rads times, and my memory's already short here, 57.325. 57.325 semicolon. And now we want to print angle. Okay. Let's see if we can get angles now from 0 to 180. Okay. And then we'll actually like tune the data so that when it's straight up, it's like 0 and then scrolls around. Then we can map it to the NeoPixels. All right. So let's see. That's at 0. Oh, and there we go. So all the way up to 359. Because 360 degrees is 0 degrees. But as I'm turning this here, it's changing angle. So this should be upside down about right here. About right there. Okay, yeah, so that's 180. That's angled. So this right here is 360. Right? So this hole here is up top. So if I put this other hole over here on top, it should be about 180. Yeah, about that. Okay. Close enough. Cool. Okay. So now let's map that over to the NeoPixels here. Okay. So we're printing this, the angle of it, and we've got 16 pixels, right? So what we need is to map that 360 degrees into 16 pixels. Okay. So we can pull it out in the calculator, or we can just uh, have the Arduino do this. Okay. So what I'm going to do here is int pix equals, let's see. So I think I need two parentheses for this. So we have, let's see, 16. Let's see, 16. So we have LED underscore count, right? Keep the code portable. Divided by, let's see, divided by 360.00. And once you put decimals on it, it's going to add the floating point. Okay, let's see, and that is times angle. There we go. Times angle. Okay. And then end that parentheses and semicolon. Now, the reason why we have this back here is so we can push it a NeoPixel over or so. Okay, we'll do that in a second. But what I want to do here is strip dot set. Actually, you know what? We have the set pixel subroutine on the bottom here. Let's look at that. Okay, so set pixel. So that would be pix, comma. Let's see, color. Color will be random. No, not random. I don't want it goofing around. I'll do like, I don't know, 1024. Let's 1024 divided by 6. I want it yellowish. 1024 divided by 6 is 170. Okay. So, comma 170 should be yellowish. And then full brightness, 255. Okay? End parentheses, semicolon, strip dot show. There we go. And then strip, whoops, dot set pixel color, pix, comma 0, comma 0, comma 0. Okay, so it's going to figure out the angle, right, of this gyroscope here, or this compass. And then we're going to take our 16 LEDs, divide them by 360 degrees, and multiply it by the angle to figure out which LED is actually going to turn on. We're going to turn that LED on at kind of yellowish at full brightness, do a strip dot show, and then turn that pixel back off, not show it, but then wait 100 milliseconds. Okay. Let's see if that works. Because it should be about that easy here. We should just be able to get that angle reading from the chip here and then map it to this. But it's not going to work quite right, and I'll show you why. It's going to work mostly right. There we go. Okay. So now, as I upload it, it's kind of going the opposite way, right? So that's centered, but as I do this, it's going away from me. Okay? So let's take it and make it opposite first. Okay? So angle equals 360 minus angle. 360? 359. 359 minus angle. Okay. So that just makes it go backwards. Okay. Now, if I were to mount this compass like upside down, I would have had to make this go backwards in code. But let's give this a try. There we go. Oh. So now as I move, in this, it's staying right there, right? But it's a little bit on the side. So this is a pixel that should be turned on, and then this is now the pixel. So it's about 2 away, right? Not a big deal, because now in our pix, we can put a parentheses around this. Actually, you know what? Let's do it in our subroutine. So pixels percent equals LED count. Okay. That way, once we hit the maximum, it goes right back to 0. So we're going to just turn it right back around. And so instead of set pix 170, we're going to add 2 to it. I don't know if we add 2 or subtract 2. I don't know the direction of this. And we want to do that in the turning off of the pixel 2. We can also change the angle. That might be the actual better way to do it, is figure out, like, if it's straight up, that light should be on. But yeah, maybe we should do it that way. We should do it the right way. But I'll try. I'll try it this way here. Oh, done uploading, and now nothing works. Okay. Let's see. Pixels percent equals LED count. Yeah, why aren't we working here? Nothing's working. Okay. Yeah, I know we messed up. Okay. So go back to Pix. Go back to Pix. Hit upload. And I'll see if it was this that messed it up or not. Pixels, percent. Yeah, okay. We'll see. Uploading. Cool. Nothing's on still. Okay. So maybe this thing messed it up. Which would be really weird. So pixels, percent equals LED count. Yeah, it should be fine, huh? Okay. Have to figure out what I'm doing wrong here. Huh, yeah, still not working. Okay. So yeah, we went back. Okay, what do we mess up here? So we turned it on, we turned it off. Oh, nope. Still not working. Huh. Okay. So yeah, what did I goof up? Uh so I'm gonna get rid of that set pixel and use this right now. I'm gonna comment this and make sure like I don't know, I'll have to figure out why. So I'll just make it red. I'll make it boring. But is this working? Yeah, the serial port's not working either, huh? Maybe the chip just toasted on me? I don't think so. Because it's reading and writing, which means it's talking to the chip. Hmm. Okay. And it's supposed to be getting stuff, and if let's uh let's put a command up here. Oh, now to begin a print ln. Print ln, and we'll say starting. Okay. Now let's see where this thing actually messes up. And I'm going to inspect the chip itself. Yeah, everything's so good here. Okay. Oh, starting. Oh, okay. So now it's running. And it's keeping red off a little. Huh. Yeah, I wonder what was goofing it up. I don't know. Maybe me touching something or like pulsing something. I don't know. It's working now though. Okay. So let's try Pix plus 2. Or let's undo that one and see if it works again. Oh, I guess it shouldn't change anything. I'll have to undo this. Whoops. And then comment this one out. But baby steps, right? See if one thing works. Yep, starting, and then it goes for it. Upload this. Okay. Let's see. That is fun though. Oh, uploading. Okay. There it goes. Okay. Okay. Seems to work all right. Now let's offset it by 2 here. So Pix plus 2, and then turn off that Pix plus 2. Okay. Because I don't know if plus 2 is going to make that LED go this way, which I want it to, or this way. We'll find out. May make it worse, might make it better, but it's easy enough to fix. Oh, yep. Made it worse. Whoa. It's not turning things off quite right either. So, oh, it's bright also. Okay. So should be okay. That's all right. Let's At least this is working here. So I can't do pix -2, okay? And that's because it'll actually go the opposite way in here. So I actually need to do pix plus, well, I typically do 14. So I have to do pix plus LED count, LED underscore count -2 to make it go the right way. That way it still keeps it all in the positive field. So copy that and then paste that. There we go. Hit upload. I want to open this up a little bit here. Okay, we'll see if this works. Nope. What did I do wrong here? Oh, somewhere where I grabbed LED count. Oh, pix plus plus. Nice. Okay. How funny. There we go. I'm going to get this right one of these days. Oh, and it's not turning on again. We'll see if we're talking still. Yeah. Yeah, sorry, shaking things again. Close this. Oh, there it goes. Okay. Cool. Wow. Okay, so it does turn on the right one. It's just, God, that's bright. Okay. Okay. But it's not turning them off. And so why isn't it turning it off? Oh, that's because this one doesn't have a subroutine. Okay, that makes sense. So I'm using a subroutine to bring the LED count back in order. This one doesn't have that advantage. So I've got to hit this and percent LED underscore count. Okay, let's give that a try. Oh man, that is bright. It's yellow. I like that it's yellow. But it's very bright. Oh, the LED count. Where is that? There it is. Whoops. Okay. We'll try this out. Done uploading. All right. So now let's change the camera angle here. There we go. Whoops. Let's see. Oh, not quite. Doesn't quite hold it. I guess this view sucks. Let's go back to here. Maybe bench. There we go. We'll do this. Okay, so this is up top now. Turn it over here. That's up top. That's up top. No, it works right. Okay. And that's up top. Yeah, so it keeps the top LED up top. And so like if I angle this up, it doesn't quite hit that one until I get like nice and high up here. But yeah, there we go. So now we're talking to a compass here and having it react to this. And so just to keep the ideas floating, it doesn't have to be the certain pixel, right? It could also be like a color. So you change the angle and now it changes the color here, right? And so as you're turning this thing, it like you point it north and it turns red, and then as you point it south, would that be on our color wheel? So if red's on one side, green's on the other, right? So it'd be green if you're pointing it south. So as you're pointing something this and that way. There we go. Okay, anyways, thanks for watching. Compasses are fun to play with. Good luck.